Gold is one of the most coveted and valuable elements on Earth, with a global net worth of 12.25 trillion US dollars. Gold is extremely rare and difficult to extract, which is the reason why it's so valuable. It also stores value and thus becomes an investment opportunity for individuals. But the curious among us must have wondered a few times about how this substance was formed and how it came to be discovered. When gold was first discovered in Egypt, it was chiefly used as a means of exchange, like how money works today. After all, only few people were vain enough to melt the metal and make ornaments from it at the time. But as time went on, people shifted to other ways of exchange, which made gold more and more of an ornamental piece, and it's obvious to see that today, after all, the gold market has a market cap of $200 billion, and many of the biggest gold companies see millions of dollars in revenue. So, that begs the question, just how is gold formed? How did it first come to being, and how is it used today? This is the story of gold. When we're talking about gold is formed, the first thing we need to understand here is that gold is much different than a lot of the items we see around us, and I'm not just talking about physical differences. If you remember high school chemistry, then I'm sure you remember that there are two types of pure chemicals. There are the compounds, which are made up of two or more materials, and then there are the elements, which are made of just one type of material. Gold belongs in the second category, which means it is comprised of only gold molecules, and such elements are made by a complex and interesting process called stellar nucleosynthesis, which occurs within the intense and extreme environments of stars. Stars form from vast clouds of gas and dust that come together due to gravitational forces. As these clouds condense, they begin to heat up, and the pressure in their cores increases. The immense pressure and temperature at a star's core facilitate nuclear fusion, the process by which atomic nuclei combine to form heavier elements. This is the heart of stellar nucleosynthesis. During nuclear fusion, hydrogen nuclei, protons, fuse together to create helium in a process known as hydrogen burning. Over time, helium can further fuse into heavier elements such as carbon, oxygen, and iron through a series of nuclear reactions. The life cycle of a star is determined by its mass. Massive stars, many times larger than our Sun, undergo a dramatic supernova explosion at the end of their lives. This explosion is a cataclysmic event that releases an enormous amount of energy, equivalent to the brightness of billions of stars, and scatters the elements formed within the star into space. However, gold, like many other heavy elements, is not formed during the regular fusion processes within stars, but rather through two distinct nucleosynthesis processes, the R process and the S process. R process, nucleosynthesis. The R process, or rapid neutron capture process, is responsible for the creation of the heaviest elements, including gold. During a supernova explosion, the extreme conditions release a flood of neutrons that bombard existing atomic nuclei, rapidly adding neutrons and forming heavier elements. This process is incredibly fast and can create elements higher on the periodic table, such as gold and uranium. S process. Nucleosynthesis. The S process, or slow neutron capture process, occurs in stars with a longer and less violent evolution, such as red giants. In this process, atomic nuclei capture neutrons over an extended period, gradually building up heavier elements, including some gold. The S process contributes to the overall abundance of gold in the universe. Within the heart of massive stars, the stage is set for a cosmic drama of unimaginable proportions. Gold's existence is intricately tied to the inner workings of these celestial giants, and the processes that unfold here are crucial in the alchemical transformation of lighter elements into precious metals. As massive stars age, they undergo a series of nuclear fusion reactions in their cores. These reactions start with hydrogen nuclei fusing into helium, releasing an immense amount of energy in the form of light and heat. This is the very energy that sustains stars and keeps them shining brightly for billions of years. Over time, as the star exhausts its hydrogen fuel, it progresses to the fusion of heavier elements. Carbon, oxygen, silicon, and eventually iron are formed through these fusion reactions. However, the journey to gold involves elements that are even heavier than iron. Iron is a crucial turning point in stellar nucleosynthesis. Fusion beyond iron requires more energy than it releases, making it an unfavorable process. This is where gold's story truly begins to unfold, as it originates from elements forged in the dying breaths of massive stars. The grand finale in the life of a massive star is a supernova explosion, a cataclysmic event that propels heavy elements like gold into the cosmos. This explosive end is essential for the distribution of these elements, including gold throughout the universe. When a massive star reaches the end of its life cycle, it can no longer support its own gravitational collapse, resulting in a violent implosion. This implosion triggers a rebound effect, leading to a tremendous explosion known as a supernova. Inside the supernova, an incredibly neutron-rich environment is created. Neutrons, one of the fundamental particles found in atomic nuclei, are released in abundance during this colossal event. Gold's origin lies in the rapid neutron capture process, R process, which occurs during the intense conditions of a supernova. In this process, atomic nuclei are bombarded by the excess neutrons, causing them to capture these neutrons rapidly and repeatedly. This rapid neutron capture leads to the formation of heavy elements like gold. The energy released during a supernova is so colossal that it expels the newly formed heavy elements, including gold, into the surrounding space. These elements are scattered far and wide, eventually becoming part of the raw materials for the formation of future stars, planets, and even life. After being ejected from a supernova, gold embarks on a cosmic journey within interstellar clouds known as nebulae. These nebulae serve as the incubators for the birth of new stars and planetary systems. Inside these nebulae, new stars are born, each surrounded by a protostellar disk of gas and dust. This disk is the crucible where planets and other celestial bodies form. As particles collide and merge within these disks, they gradually accumulate heavier elements, including gold. The heavy elements inherited by planets and other celestial bodies are a testament to the supernovae that came before them. Gold, along with its counterparts, is present in the raw materials that give rise to planets like Earth. On Earth, the heavy elements, including gold, are not uniformly distributed throughout the planet. During its early formation, Earth experienced extreme heat and pressure, causing materials to differentiate. This process led to the sinking of heavier elements like gold into the planet's core. Gold is valued based on a combination of factors that influence its price in financial markets and its perceived worth as a precious metal. The basic principle of economics applies to gold. When demand for gold exceeds its supply, its price tends to rise. Factors affecting supply and demand include jewelry demand, industrial uses, central bank purchases, and mining production. Another major factor becomes political instability, economic uncertainty, and inflation, which can drive investors to seek refuge in gold as a safe haven asset. During times of crisis, the demand for gold often increases, driving up its value. The price of gold is often inversely correlated with the strength of major currencies like the US dollar. When the dollar weakens, gold becomes relatively more attractive to investors, leading to higher prices. The opportunity cost of holding gold is influenced by interest rates. When interest rates are low, the cost of holding non-interest-bearing assets like gold is lower, making it more attractive. Market sentiment and speculative trading can have a significant short-term impact on gold prices. News events, investor sentiment, and trading patterns can lead to rapid price fluctuations. Overall, gold's value is a complex interplay of economic, geopolitical, and market forces. As a tangible asset with a long history of value, it continues to serve as a store of wealth and a hedge against economic uncertainty, making it a unique and enduring investment option. With an understanding of the cosmic origins of gold, we can now explore how this precious metal becomes part of Earth's geological processes. While Earth was still in its formative stages, it experienced a period of intense meteorite bombardment. Some of these meteorites carried precious metals like gold, delivering them to our planet. A significant portion of Earth's gold is believed to have been transported to the crust through hydrothermal processes. This involves hot, mineral-rich fluids rising from the mantle and interacting with the surrounding rocks. These fluids can carry dissolved gold and deposit it in veins or deposits as the temperature and pressure change. Over geological timescales, the Earth's surface is shaped by weathering and erosion. These processes can expose gold-bearing rocks and release the gold particles into streams and rivers, where they can accumulate in placer deposits. Human beings have been mining for gold for thousands of years. Today, modern mining techniques involve extracting gold from ores and deposits using a variety of methods, including cyanide leaching, gravity separation, and flotation. Gold's journey through the cosmos is not limited to the realms of astrophysics and geology. It extends deeply into the cultural and economic fabric of human society. For millennia, gold has held a unique place in human culture and aesthetics. Its radiant luster and malleability made it an ideal material for crafting exquisite jewelry, ornaments, and ceremonial objects. It has symbolized wealth, power, and beauty across diverse civilizations, from the Egyptian pharaohs to the Aztec rulers. Gold's intrinsic value and rarity have made it a preferred medium of exchange and a store of value throughout history. The gold standard, where the value of currency was tied to a specific quantity of gold, played a central role in global monetary systems for centuries. In the modern world, gold serves a multitude of purposes beyond adornment and currency. It is a vital component in electronics, as it is an excellent conductor of electricity and resists corrosion. Dentistry uses gold for dental crowns and fillings. Furthermore, gold nanoparticles hold promise in various medical and scientific applications, from cancer treatment to drug delivery. The quest for gold has often led to transformative events in history, none more emblematic than the gold rushes of the 19th century. These rushes shaped landscapes, economies, and societies, but they also left a significant environmental footprint. The discovery of gold in California in 1848 sparked one of the most iconic gold rushes in history. Tens of thousands of prospectors, known as 49ers, flocked to California in search of their fortunes. This rapid influx of people led to the growth of cities, the development of infrastructure, and profound societal changes. However, the pursuit of gold during these rushes had significant environmental consequences. Mining operations disrupted ecosystems, led to deforestation, and contaminated waterways with mercury and other chemicals used in the extraction process. The scars of these activities are still visible in certain regions today. In the modern era, gold mining remains a critical industry with a global footprint. However, it faces significant challenges, including environmental concerns, labor issues, and ethical considerations. The extraction of gold from ores and deposits can have adverse environmental effects, such as habitat destruction, soil erosion, and water pollution. Modern mining operations strive to implement sustainable practices, minimize their ecological footprint, and rehabilitate mined areas. Gold mining industry has faced scrutiny for ethical issues, including human rights abuses, child labor, and the financing of armed conflict in certain regions. Efforts are being made to ensure that gold is sourced responsibly through initiatives like the Kimberley process and fair trade gold certification. Technological advancements in mining have the potential to reduce the industry's environmental impact. These innovations include the use of cleaner extraction methods such as heap leaching and bioleaching, as well as the development of environmentally friendly mining equipment. As our understanding of gold and its sources deepens, scientists are exploring unconventional sources of gold beyond our planet. For example, gold's unique properties, such as its excellent reflectivity, make it valuable for space exploration. It is used in spacecraft components and as a coating for telescope mirrors. In the future, asteroid mining could become a reality, potentially opening up new sources of gold and other valuable resources. The demand for gold in technology continues to grow as electronic devices become more prevalent. Researchers are exploring ways to recover gold from electronic waste, reducing the need for traditional mining. In the grand tapestry of the cosmos, gold emerges as a symbol of both our scientific understanding and our enduring fascination with the universe. From its genesis in the fiery hearts of massive stars to its presence on Earth, gold's journey is a testament to the interconnectedness of the cosmos and the indomitable human spirit. As we continue to explore the depths of the universe and the intricacies of our own planet, the allure of gold remains undiminished. Its beauty, rarity, and versatility continue to captivate us, reminding us that even the most precious of elements have humble origins in the crucibles of distant stars. In the quest for gold, we find not only wealth but also a deeper connection to the cosmos and an enduring testament to human curiosity and ingenuity. The story of gold is a story of discovery, transformation, and the eternal allure of the unknown.